Good morning, children. In today's class, we are going to learn some multiple choice questions from chapter 3, Integral Calculus 2. Question number 1. Area bounded by the curve. Between the limits are given, x-axis given. We remember area, the formula integral a to b y dx. In this question, a to b, 0 to 4. Y is x into 4 minus x dx. But we remember in integration, product rule is not there. So let us multiply first before integration. X into 4 minus x into x. As I integrate 4, x will become x square by 2 minus x square will become x cube by 3. Guess what formula we are using? Integral x power n dx equals x power n plus 1 by n plus 1 plus c. As I apply this formula, n is 1, so 1 plus 1 by 1 plus 1. n is 2, 2 plus 1 by 2 plus 1. And it is definite integral, we need not put c. Between the limits 0 and 4, I can cancel. Wherever x comes, let me put 4. 2 x square, that is 4 square. X cube, that is 4 cube by 3. Upper limit over. When I put lower limit, x 0, so this full term, when I put x 0, my answer becomes 0. As I simplify, 4 square, 16 into 2, 32 minus 4 cube, 64 by 3. As we take LCM, 3 into 32 minus 64. My answer 32 by 3 square units. Option C will be the right choice. Question number 2. Area bounded by the curve y equals e power minus 2x. Between the limit 0 to infinity. Here x limits are given, so it is about x-axis, and we recall the formula area is integral a to b. Here the limits are 0 to infinity. Y dx. Y is e power minus 2x dx. As we try to integrate, e power minus 2x becomes e power minus 2x by minus 2. Recall the formula integral e power ax dx is e power ax by a. Here a value minus 2, e power minus 2x by minus 2 between the limit 0 and infinity. Put upper limit e power minus 2 into infinity infinity minus. Put lower limit e power 0 by minus 2. As we simplify, e power minus infinity reduces to 0. 0 by minus 2 is again 0. Minus and minus I can cancel. It is e power 0 which reduces to 1 by 2. So the right option 1 by 2 square units. Option B is the right choice. Question number 3. Area bounded by the curve y equals 1 by x between the limits 1 and 2. Area between x values 1 and 2 we call integral a to b y dx. As we substitute, area equals integral 1 to 2. Y is 1 by x dx. We remember the integral formula 1 by x becomes log x between the limits 1 and 2. As I substitute upper limit, it is log 2 and the lower limit log 1. Whenever minus comes, remember it is division. Minus in logarithm leads to division. Log 2 by 1 is log 2. Square units, option A is the right choice. Question number 4. Marginal revenue is given. We need to find out the revenue function. Recall the formula. Revenue is integral MR dx. Here R is equal to integral MR is e power minus x by 10 dx. Remember the formula. Integral e power is e power the same divided by the coefficient of x. I have minus 1 by 10. So recall the formula. Integral e power ax dx is e power ax by a. As I substitute and I reciprocate, minus 10 e power minus x by 10 plus c. Whenever x is equal to 0, the output is 0. We remember revenue is also 0. As I substitute, R becomes 0, minus 10 e power again minus x by 10 is 0 plus c. We remember e power 0 is 1. So, c is equal to minus 10 goes to the other side as plus 10 e power 0. And e power 0 is 1. So, 10 into 1, that is 10. Once I know c value, let me substitute in equation number 1 to arrive at the revenue. R equals minus 10 e power minus x by 10 plus c. C value is 10. If I take 10 as common to bring about the multiple choice answers, let me take 10 as common. I get 10 by 10 1, 10 by 10 1. Here minus symbol, e power minus x by 10. And we have option C to be the right choice. Question number 5. If MR and MC denotes the marginal revenue and marginal cost functions, then the profit function is, we recall the formula, profit is revenue minus cost. How to find revenue? It is integral marginal revenue dx. And cost is integral marginal cost dx. So P will be integral MR dx minus integral MC dx. Out of the 4, we get option A to be the right choice. I get integral MR minus MC dx plus constant. Question number 6. The demand and supply functions d of x and s of x are given. Under perfect competition, we need to find the equilibrium price. We know under perfect competition, d of x must be equal to s of x. That is, under perfect competition, demand and supply must be equal. As I equate, demand is 16 minus x square. Supply is 2x square plus 4. Let us try to solve this by bringing x square term to the same side. I get minus x square minus 2x square is 4 minus 16. So the numbers together, x square together. Minus x square minus 2x square is minus 3x square. 4 minus 16 is minus 12. I need x square. Minus 12 divided by minus 3. X square is 4. X is equal to plus or minus 2. But x represents output. So, x is equal to plus 2 is valid. Option A will be the right choice. Question number 7. Given the marginal revenue and marginal cost, we need to find the profit function. Profit function capital P is integral MR minus MC dx. Integral MR minus MC dx. As we substitute, integral MR is 30 minus 6x. MC is minus 24 plus 3x dx. As we simplify, 30 minus 6x minus of minus 24 is plus 24. Plus 3x will become minus 3x dx. As we reduce, minus 6x minus 3x minus 9x. 30 plus 24, 54 dx. Now let us integrate. Minus 9, x becomes x square by 2 plus 54 becomes 54 into x plus a constant, say k. Minus 9x square by 2 plus 54x plus k. Option D will be the right choice. Question number 8. Given demand and supply function, under perfect competition, we need to find the equilibrium demand. So, under perfect competition, d of x equal to s of x. d of x 20 minus 5x, s of x 4x plus 8. As we try to simplify, bring 4x to the left, minus 5x minus 4x. 8 plus 20 goes as minus 20. Minus 9x is minus 12, or x is equal to minus 12 by minus 9. Cancelling 3 table, it reduces to 4 by 3. My question is to find equilibrium demand. So, substitute x is equal to 4 by 3 in the demand function. d of x is equal to 20 minus 5x. That is 20 minus 5 into 4 by 3. That is 20 minus 5 fours are 20 by 3. Taking LCM, 3 into 20 minus 20, that is 60 minus 20 by 3. So my answer is 40 by 3 and the right option is C. Question number 9. If the marginal revenue MR is given, we need to find the average revenue. What is average revenue? It is revenue divided by x. Let us calculate what is revenue. Integral MR dx. As I substitute integral, what is MR? 35 plus 7x minus 3x square dx. As we try to integrate, R equals 35x plus 7x square by 2 minus 3x cube by 3 plus a constant k. 35 constant will become into x. 7x will become x square by 2. 3x square will become x cube by 3. As we cancel and write, whenever x is equal to 0, revenue is also 0. As I substitute, x 0, 0, 0. So, R is 0. All these things become 0, 0, 0 plus k. That implies k value is also 0. So, R is 35x plus 7x square by 2 minus x cube. My question is to find average revenue. Each term divide by x. 35x by x, 7x square by 2x minus x cube by x. As I divide, we get 35 plus 7x by 2 minus x square. So x cancels, x square by x is x cube by x is x square. So the right option is 35x plus 7x by 2 minus x square. Option B is the right choice. Question number 10. The profit of a function is maximum. What is the condition? We know profit is equal to revenue minus cost. If the function is maximum, P is maximum when the first derivative of profit is 0. So if I substitute, dP by dx is nothing but dr by dx minus dc by dx. This I can say marginal revenue and this I can say marginal cost. So this condition reduces to mr minus mc equal to 0, or in other words, according to the choice given, I can rewrite this as mc minus mr equal to 0. Option A is the right choice. Question number 11. For the demand function P of x, the elasticity of demand with respect to price is unity. Then which of the condition is true? We recall the formula for elasticity of demand. Eta d equals minus p by x dx by dp. Given elasticity is 1. So in the place of eta d, let me put 1. As I separate the variables p by dp, I will take to the left as dp by p, and then we try to integrate on both the sides. As we try to integrate, dp by p is log p, dx by x is log x. Let us introduce constant also as log k. And we remember in logarithm, there are two terms, one with plus, one with minus. Plus term will come in the numerator, minus term will come in the denominator. So k in the numerator, x in the denominator, we get log of k by x. Both the sides, we have single logarithm. I can delete the logarithm. We get p is equal to k by x. Cross multiplying, p into x is k. And we remember, p into x is nothing but revenue. So we derive revenue is constant and option A will be the right choice. Question number 12. The demand function for the marginal function we need to find. mr is given. Let us find out what is r. r is integral mr dx. As I substitute integral 100 minus 9x square dx. As we integrate, 100 constant becomes into x minus 9 x square becomes x cube by 3 plus constant. As we simplify, and whenever x is 0, the output, we have revenue also 0. As I substitute r0, 100 into 0, 0, minus 3x cube 0 plus k. This leads k also to be 0. As we substitute r equals 100x minus 3x power 3. What is my question? I need to find out the demand function. Demand function represents average revenue, that is divide by x. So average revenue, the formula R by X. As we divide 100x by X minus 3x cube by X. So we get the demand function to be x and x cancels, 100 minus x and x cube. As we cancel, we get 3x square. So 100 minus 3x square we call as the demand function, and option A is the right choice. Question number 13. When x naught is 5 and p naught is 3, we need to find the consumer surplus for the demand function 28 minus x square. Let us recall the formula. Consumer surplus is integral 0 to x naught f of x dx, that is a demand function, minus x naught p naught. As we substitute 0 to x naught is 5, f of x is the demand function, that is 28 minus x square dx, minus x naught value 5 and p naught value 3. As we simplify, 28 becomes 28x minus x square becomes x cube by 3. Between the limit 0 and 5, minus 5 3s are 15. As we try to simplify, putting upper and lower limit, 28 into 5 minus 5 cube by 3. When I put lower limit, 28 into 0, 0, x cube also gives me 0. So lower limit is 0 minus 15. As we simplify further, 3 is the LCM. 3 into 5 into 28 gives us 420 minus 5 cube is 125 minus 3 into 15, 45. As we try to simplify, 250 by 3 units, option B will be the right choice. Question number 14. When x naught and p naught are given, we need to find the producer's surplus. Recall the formula. Producer surplus equals x naught p naught minus integral 0 to x naught g of x dx. That is the supply function. In this question, x naught is 2, p naught is 12 minus integral 0 to 2. The supply function is 2x square plus 4 dx. As we try to integrate, 2 into 12, 24, 2, x square becomes x cube by 3 plus 4 becomes 4x between the limit 0 to 2. X square becomes x cube by 3, 4 becomes 4x. As we try to simplify, it is 24 minus 2 into x cube, 2 cube by 3 plus 4 into 2. As we complete upper limit, let us put 0. 0, 0. So the lower limit just gives me 0. Let us remember there is a minus symbol which should be guarded for both the terms. Minus 8 2s are 16 by 3 minus into plus is minus 4 2s are 8. Most of us make mistake forgetting minus here. Remember, this minus is common for both the terms. So take minus for both the terms, and as I take LCM, 3 into 24 minus 16 minus 3 into 8. As we simplify, we get 32 by 3 units, and option C is the right choice. Question number 15. Area bounded by y equal to x. Between the lines y is equal to 1, y is equal to 2 with y axis. My question is y axis. Let us remember the formula. Area is integral c to d x dy. Here the limits are 1 and 2. x is nothing but y dy. As we integrate, y becomes y square by 2 between the limits 1 and 2. Substitute upper limit 2 square by 2 minus lower limit 1 square by 2. LCM is 2. 2 square is 4 minus 1 square is 1. So we get 3 by 2. So the right option is C, 3 by 2 square units. Question number 16. We need to find the producer's surplus when the supply function is given and x naught is given. First of all, let us find out what is P naught. 3 plus x. In the place of x, we need to put 3. My answer is 6. As we know x naught and P naught, producer surplus is x naught P naught minus integral 0 to x naught g of x dx. That is the supply function. Here x naught is 3, P naught is 6 minus integral 0 to 3. What is g of x? The supply function, that is 3 plus x dx. So we simplify. 18 minus 3 will become 3x plus x will become x square by 2 between the limit 0 and 3. As we simplify, it is 18 minus 3 into upper limit 3 plus 3 square by 2. The lower limit 0, 0. So it just reduces to 0 only. As we simplify, P of S is 18 minus 3 3s are 9. Again minus into plus is minus 3 square 9 by 2. As we take LCM, it is 36 minus 18 minus 9. Or we simply get 9 by 2 units. Option B is the right choice. Question number 17. Marginal cost function is given. We need to find AC. First, let us find out what is C. We recall the formula. Cost is integral MC dx. That is integral 100 root x dx. As we simplify, 100 will come out. Root x, the power is 1 by 2. Recall the formula. Integral x power n dx is x power n plus 1 by n plus 1. As I substitute x power half plus 1 by half plus 1 plus constant k. As we simplify, x power half plus 1, 2 plus 1, 3 by 2. Denominator also 2 plus 1, 3 by 2 plus k. Given total cost is 0 when the output is 0. So x is 0 implies cost is also 0. As I substitute 0, x is also 0 plus k. That gives us k value is also 0. As I substitute C equals 100, denominator 3 by 2, if I reciprocate, it is 2 by 3 into x power 3 by 2. As we multiply and simplify, we get 200 by 3, x power 3 by 2. This is cost. My question is to find average cost. So what is average cost? Cost divided by x. As I divide cost by x, 200 by 3, x power 3 by 2 divided by x. As I simplify, it is 200 by 3, x power 3 by 2 minus 1, that is 1 by 2. So the right option is A. Question number 18. The demand and supply functions are given. We need to find the equilibrium quantity x naught. We know at equilibrium, the demand and supply are equal. P of x equal to S of x. That is, x minus 5 the whole square is x square plus x plus 3. As we try to simplify, expanding the LHS, it is a minus b the whole square. That is, x square minus 2 into x into 5, 10x, plus 5 square, RHS, x square plus x plus 3. In both the sides, x square we can cancel. I have minus 10x, bringing this x to the left, 3. 5 square is 25 and goes to the right as minus 25. This is minus 11x equals to minus 22, or x is equal to minus 22 by minus 11, which reduces to 2, and option B is the right choice. Question number 19. The demand and supply functions of a commodity are d of x and s of x. We need to find the equilibrium price P naught. As we know, at equilibrium, demand equal to supply. So d of x equal to s of x. 25 minus 2x equals to 10 plus x by 4. As I cross multiply, 4 into 25 minus 4 into 2x is 10 plus x. Bringing x to the same side, minus 8x minus x equals to 10 minus 100. That reduces to minus 9x equals minus 90. X is equal to minus 90 by minus 9, or x is equal to 10. But my question is to find out the equilibrium price P naught. So, substitute 10 either in d of x or s of x. As I substitute here, it is 10 plus 10 divided by 4. That reduces to 5, and so the right answer P naught equal to 5, option A is a suitable choice. Question number 20. If MR and MC denote the marginal revenue and marginal cost, and MR minus MC is given, my question is to find the maximum profit. We remember the condition for maximum profit. MR minus MC equal to 0. That is 36x minus 3x square minus 81 equal to 0. Dividing by minus 3, I get minus 12x plus x square plus 27 equal to 0. Or as I rewrite, x square minus 12x plus 27 equal to 0. As we try to factorize 27, and I need minus 12. The two factors are minus 9, minus 3. Let us cross check. Minus into minus plus. 9 3s are 27, and minus 9 minus 3 is minus 12. As we substitute, x minus 9 into x minus 3 is 0, or x is equal to 9, 3. For maximum profit, MR minus MC, the whole dash must be negative. As I know what is MR minus MC, let me differentiate. 36x will become 36 minus 3 into x square becomes 2x, and it should become less than 0. When I put x is equal to 9, we get 36 minus 3 2s are 6 into 9, that is less than 0. Therefore, profit is maximum when x is equal to 9, and option C is the right choice. Question number 21. If the marginal revenue of a firm is constant, that is MR is a constant, Then we need to find about the demand function. When I know MR is constant, let me integrate. Integrate MR dx, I will get revenue. That is integrate K dx. R is equal to Kx plus some constant, say K1. When X is 0, revenue 0, K1 is also 0. So, revenue equals Kx. My question is demand function, that is average revenue. So, I need to find what is R by X. That is Kx by X, which is K. So, demand function is K and K is nothing but MR. So this implies the demand function and marginal revenue are equal. Calling this as 1, MR as K, calling this as 2. So 1 and 2 implies P equals MR and the right option is A. Let us see once again. Given MR is K. As I integrate, I get R, the revenue as Kx plus K1. When I put X 0, R 0, I get K1 also 0. So, revenue equal to Kx. My question is to find the demand function. Demand function is nothing but average revenue. So, dividing by X, again I get K. Demand function is K. Marginal revenue is also K. So 1 and 2 imply demand function and marginal revenue are equal. So option 1 is the right choice. Question number 22, for a demand function P, if dP by P integral is K integral dx by x, what is K? As I bring K in, I can rewrite this as integral dP by P is integral K by x dx. Taking differential on both the sides, integral can be cancelled. So I can say dP by P equals K by x dx. My question is to find K. So keep K here, take dx by x to the other side. I get already dP by P is there. Dx by x will go as x by dx. As I rearrange, K equals x by P dP by dx. We recall the formula for eta d, that is minus P by x dx by dP. Here just the reciprocal is available and minus symbol missing. So as I compare these two, I can write K equals minus reciprocal of eta d, that is minus 1 by eta d, and option C is the right choice. Question number 23, area bounded by y equals e power x between the limits 0 and 1. We recall the formula A equals integral y dx between A and B. Here the limits are 0 to 1 and y is e power x dx. E power x, the integral is also e power x between the limits 0 and 1. Wherever x comes, let us put upper limit 1 minus. Wherever x comes, let us put lower limit 0. E power 1 is e and e power 0 is 1. So area is e minus 1 square units and option A is the right choice. Question number 24, find the area bounded by the parabola y square equal to 4x with its latus rectum. One method, directly we can remember the formula. Whenever we say bounded by latus rectum, y square equal to 4ax, area is 8a square by 3. In this question, y square equal to 4x is given. As I compare with y square equals 4ax, I get 4a is 4 or a value 1. So area will be 8 into 1 square by 3, that is 8 by 3 square units. So method number 1, directly remember the formula whenever it is y square equal to 4ax and bounded by latus rectum. The formula is 8a square by 3 for the area covered. Here a equals 1. As I substitute, I just get 8 by 3. Option B is the right choice. Question number 24, second method. Y square equal to 4x. I compare with y square equal to 4ax. That tells me 4a is 4 or a equals 1. Whenever we mean latus rectum, the limits are 0 and a. So, latus rectum implies the limits are 0, a. That is, in this question, 0 and 1. And we have two portions, up and down. So, the area is 2 times integral 0 to 1 y dx. So, here a is 1. And there are two portions up and down. Let us calculate first quadrant, multiply by 2. As I substitute, y is nothing but root of 4x from the question. Root 4, I will say 2. So I can rewrite this as, there is a 2 already. Root 4 is 2. Integral 0 to 1. X power, root tells me 1 by 2. So root x tells me x power 1 by 2 dx. As I integrate, 2 into 2, 4, x power half plus 1. Denominator also half plus 1 between the limits 0 and 1. 4 into x power half plus 1, I can say 3 by 2. Denominator also 2 plus 1, 3 by 2. Between the limit 0 and 1. Whenever I put 1, power any number gives me 1 only. So, the numerator, as I put 1 power any number 1, 0 power any number 0. The denominator 3 by 2, I reciprocate, it goes as 2 by 3. So my final answer, 8 by 3 square units. So option B is the right choice. You can either do by the first method or you can try the second method. Question number 25, area bounded by y equals mod x between the limits 0 and 2. What do you mean by mod x? It is simply x when x is greater than or equal to 0 and it is minus x when x is less than 0. In this question, the limits are 0 and 2. 0 and 2 tell me x is positive. So between 0 and 2, x is positive. Therefore, y is equal to x. Now, what is my question? Area. It is integral a to b y dx. Here the limits are 0 and 2. Y is nothing but x dx. As we integrate, x becomes x square by 2 between the limit 0 and 2. Put upper limit 2 square by 2. Put lower limit 0. As we simplify, it is 4 by 2 or I get 2 square units. Option C is the right choice.